So, back to my instructions. We're up to number 6. So we've just done number 6. All right. Now we're up to number 7. We insert a linear fit, and then we're going to insert 2 more lines. So we're really close to the end now. So insert a linear fit. I personally, just in case, I'm just going to get rid of this one so it doesn't put a graph line on the wrong one. You can make it as large as you can on the screen. We'll need that later. And you just click this little one here, linear fit, and there it is. Tells you the gradient, tells you the intercept. All right. Now, the next bit, the number 8 and number 9, we want this little button for curve fit. And the curve fit, we want to manually tell it. Now remember, our gradient was 5. So I'll make my gradient 5, and my intercept I'll make 0.2. And it shows you where it's going to plop it on your graph. Okay? It's way up there. That's the line of best fit one. You can drag these around. That's the manual fit one. Okay? Now I'm going to put in the second one. So put another one in. We want 2 of them. Well, you'll see why in a minute. So I'll make that 5 as well, but I'll put that as negative 0.2. So it's below all the dots. Click OK, and there it is there. Move this down here. So we got our 3 lines. Now how we make them draggable. You double click, and you select the bottom box. And these 2 little diamonds show up. Okay? These 2 little diamonds, we can make this one the steepest one. So we want to put these 2 little diamonds, drag them around, and what you're looking at is the left and right edges of those error bars. And I'm aiming at the second to last left corner and the very first right corner to make the steepest line possible that goes through all the error bars. Okay? So that's a gradient of about 5.2. All right, so it's going to be a little bit different for everybody, but that's the idea. So to drag this one, you double click, enable drag, and this will be my shallow line. So I'm going to aim at the left edge of the first error bar and the right edge of probably the last error bar. So you sort of have to go by here. You want to go through all the error bars you can. And this now has to be dragged down a bit. There we go. That's pretty good. All right. So it looks really close to the one we started with. The numbers are a little bit different if you don't notice, if you haven't noticed, but it works. Okay. So that's how you get a graph with 3 lines in Logger Pro. Now, what you do with these numbers. Okay, so what you do with these 3 numbers. Now, if you haven't noticed, I've cheated. I've gone back and I'm now showing you the one that I had made before the video started. But it's the same process, okay? It's just where the lines were dragged to, so the intercepts are a bit different. Now, the pattern we're looking at here is the steep line is on the top, the line of best fit is in the middle, and the shallow line is on the bottom. So what you want, according to your instructions, remember, these were your instructions, is you want the equation of the line with uncertainties. It says right here how to work out the uncertainties. Okay? So, my interpretation is we're up to number 11. Okay? This is what we're aiming for. That red one is the final target. Now, how that works is, if we look down here, the line of best fit was 5, the steep was 5.2, the shallow was 4.8, and we do the subtraction and half of that subtraction. So basically, you're averaging. Well, you're taking half the difference. Basically, you're taking half the difference between the 2 gradients, and that works out to 0.192. Same thing for the intercepts. The 3 different intercepts are there. All this data was on the screen. Okay? So you don't need Excel to work this out. You can just do it in the calculator. But this is just for the video. And what that turns into is we want to round the uncertainty to 1 sig fig, not 0.192, but 0.2. We want to round the uncertainty to 1 sig fig. So this 0.024 becomes 0.02. And how this finally shows up. Your 5 came from your line of best fit. That came from this one right here, the 5.04. So I'll actually show you on the Word file. So the original one, without any rounding, looks like this. Your line of best fit gradient plus or minus half the difference of your steep and shallow line. Then your horizontal axis. Your vertical intercept of your line of best fit plus or minus half the difference of the two other lines, intercepts. So the 0.192 gets turned to 1 sig fig. All right. The 0.02 turns to 1 sig fig. Then you pair up decimal places with the number in front. So the 5.048 goes to 5.0 because there's one decimal place. The 0.02095 goes to 2 decimal places because the uncertainty has 2 decimal places. Okay, so now you are done with these parts of your instructions. Calculate the acceleration of the ball is basically you remembering that the gradient is 1/2 g. All right. Now, another part of your instructions are your analysis section. So you can pause this and have a read. You don't need me to read it for you. But what that means is this. So yet again, you don't need me to read it for you. You can just pause the video, have a read. Okay. Now, this is a lot of mathematics, but basically it equates to, it's a good experiment. Your uncertainties were small. Your expected gradient was really close to your theoretical gradient. And you didn't have much wiggle in your dots. The same kind of thing can be done for the intercept. For our data, remember, these 3 lines. For those 3 lines, the intercept, you could probably say something like this. Again, you don't need me to read it to you. You can pause the video. But you don't want to go crazy and say, oh, I expected 0 and I got 0.02. Basically, it's good. It's close enough to 0. You don't have anything to fret about. So that's a little extra. The goal of this, remember, was to learn how to drive the software and make something like this. So you might have to replay the video a few times and figure out how to get Logger Pro to make you 3 lines and drag these things around so that you have all the information you need to make a formula that looks something like that red one right there. Good luck.